Right model. The two strands which you see are running anti-parallel to each other are polynucleotide. The backbone is made up of phosphate and sugar. This bond is formed between the 3 carbon atoms of the sugar of one nucleotide to the 5 carbon atoms of succeeding nucleotide. This chemical model is appeared to be a staircase. Each strand turns 36 degrees. The distance between these strands is known as pitch and its value is 34 angstrom. Each base pair distance of its value is 3.4 angstrom. Thank you.
Hello everyone, let us take a closer look to this model in which we have shown motion of moving hand. We use thermocol for making humerus, radius and ulna. For muscles which causes the motion, we used balloon and a string. As soon as the balloon gets filled with air, the radius and ulna moves in upward direction. But as soon as the air expelled out from the balloon, the motion of radius and ulna could be seen in downward direction. Let us do it practically so it will be more clear. As soon as the balloon gets filled with air, the radius and ulna moves in upward direction. But when this air moved out from the balloon, the motion of radius and ulna could be seen in downward direction. That's all for the project. Thank you.
Working model of human urinary system. Let's begin with a question that why do we need excretory system? Slowly we go through all the points through this working model. Urinary system, also known as the renal system or urinary tract, it consists of a pair of kidneys, one pair of ureters, a urinary bladder and a urethra. The purpose of urinary system is to eliminate waste from the body, regulate blood volume and blood pressure, control levels of electrolyte and metabolites, and regulate blood pH. The kidneys have an extensive blood supply via the renal arteries, which leave the kidneys via the renal vein. Each kidney consists of a functional unit called nephrons. Following filtration of blood and further processing, waste in the form of urine exit the kidney through the ureters, the smooth muscle fibers that propel urine towards the urinary bladder, where it is stored and subsequently expelled from the body by urination. Average urine production in adult human is about 1 to 2 liters per day, depending on state of hydration, activity level, environmental factors, weight, and the individual's health. If we see it again concisely, so urine is formed in the kidney through the filtration of blood, then passed through the ureters to the bladder, and during urination the urine is passed from the bladder through the urethra to the outside of the body. Thank you.
Hello everyone, we are going to present our model of double circulation in which the blood flows strictly by a fixed route through blood vessels, namely arteries and veins. The completely four-chambered heart actually comprises of two separate pumps working in unison. The right side of the heart serves as the one pump and it contains only deoxygenated blood received from the body and sent to the lungs, which is known as pulmonary.
The left side of the heart serves as the second pump. It contains only oxygenated blood received from the lungs and sent to the body, which is known as systemic circulation. Thus, there is no mixing of oxygenated and the deoxygenated blood in the heart. The blood passes the heart twice, once along with the pulmonary circuit and second time in systemic circuit. This type of blood circulation is known as double circulation.
Now let us practically show you all how it works. When the blood comes from the body into right auricle, it contracts and blood enters the right ventricle through tricuspid valve. Then right auricle relaxes and deoxygenated blood from the body enters it through superior and inferior vena cava. Right ventricle contracts and blood is pumped into pulmonary artery and carried to the lungs, where it gets oxygenated. Similarly, in the same way, left auricle contracts and blood enters left ventricle through bicuspid valve. Left auricle relaxes and oxygenated blood enters it from lungs through pulmonary vein. Left ventricle contracts and blood is pumped into largest artery aorta and taken to all body parts. And that's all about our model. Thank you.
See, we have left kidney and right kidney, and the main function of these kidneys is to purify the blood and send the filtered blood back to the heart, maintaining the fluid balance in our body. Then the kidney receives the blood for filtration from the renal arteries, and then these renal arteries get divided into more segmented arteries. And in our human system, we have three major parts of urinary system, that is ureter, urinary bladder, and urethra. In human body, we have two ureters which are narrow in shape and that contains urine in their body. The main function of the bladder is to store the urine and to allow the urination to be flow into a more regulated and in a more controlled way. Then the urine will come out of the bladder via urethra, and urethra is the linkage between the bladder and outside of the body. Then the brain signals the bladder muscles to tighten up, that squeezes the urine out of the muscles, and that comes out through the passage, that is urethra, out of the body. Now I would like to demonstrate you how this model that we all have made, how it works. So this is the fluid that we have, and we will pour it into both of these kidneys, the right kidney and the left kidney respectively. And as you can see that with this ureter, that is a pipe through which it is moving down, and this is the bladder where it gets stored, and then it finally reaches the urethra, and that is how our kidney model works, or the respiratory system of our body works. Thank you.
Hello everyone, myself Kushak Joshi. I am from Archies High Secondary School, and today I am going to perform an experiment in order to demonstrate that the air moves from the region of high atmospheric pressure to the region of low atmospheric pressure. So for performing this experiment, we will require a plate, a candle, some water and a candle. So first of all, we will make this candle to firmly stand over our surface, and now we will put some colored water over our saucer. And after that, we will lighten this candle up. Let's wait for a while so that this candle can be lightened up. And now we will put this glass over this lightened candle, and let's see what will happen. So when we put this glass, when we have put this glass over this lighted candle, this candle has been burned out. This happened because it not able to consume the oxygen, because oxygen inside the glass was limited and it has emptied out. So as a result, it burned out. And now. One more thing we have observed, that some amount of water has been risen up in this cup. This is because inside this cup there is the region of low pressure, and outside the cup there is the region of high pressure. In addition, the air is heavy. So there is a law that is followed by the air, that they move from the region of high atmospheric pressure to the region of low atmospheric pressure. And we know that in water some considerable amount of gases are dissolved, and they had followed that law, due to which they made water to rise up in this glass where there is the low pressure and light air. And as a result, this water has been risen up, and by this we can conclude that yes, air moved from the region of high pressure to the region of low pressure. Thank you.
Myself Ayushi Gupta
and myself Vishakha Agarwal
from Archies Higher Secondary School are going to present an activity which tells us about the relation between pressure and depth. Vishakha, do you know what is pressure?
Yes, I know. Pressure is a force per unit area. Equal pressure is exerted from all the directions, and most importantly, pressure depends on the depth.
Can you explain with the help of an activity?
Yes, sure. So I have taken a vessel, and in this vessel I have put the water, and now I am going to remove the tapes. In these tapes there are 3 holes, and when we remove this tape, then we can see that the water is coming out from this. So as you can see that water from the topmost hole is covering the minimum distance, and water from the bottommost hole is covering the maximum distance. So Aishu, what you can conclude from this activity?
I can conclude from this activity that water which is coming from the bottommost hole was at the maximum height, whereas the water which was coming from the topmost hole was coming with the minimum height. So we can see that pressure depends on the depth, and as the depth increases, the pressure also increases. Thank you.
Hello everyone, this is me Adi Prajapati.
And myself, Satya Prakash.
Would like to show the demonstration on Newton's second law. By the way, do you know what is Newton's second law?
I don't know, can you please explain me?
I can explain you. Let me tell you that Newton's second law states that the rate of change of momentum is directly proportional to the applied force in the same direction.
It's not easy for me to understand. Can you please elaborate?
Yes, let me tell you that in simple words we could say that force is defined as the product of mass and acceleration.
Well, I understood this. Can you please show me a real life example?
Yes, I will show you through this model. First we will put the heavier one ball like this. We will see that the hole has made, and similarly we will do with this the lighter ball. What you will observe?
The bigger ball has made a big hole and the smaller ball has made a like shallow hole. So can you explain me please how this happens?
This happens because when the ball is thrown from the height, it exerts the force on the sand, which therefore makes the hole. But there is a major difference in the size of the hole. So here the Newton's second law works. Let me tell you that we know that force is equal to mass into acceleration, and we know that acceleration due to gravity is constant. So there is a difference of mass. As we said that the heavier, we have put the heavier ball so it makes a heavier hole, and in the smaller ball we have made the smaller hole. Similarly, we can say that Newton's second law works here.
Oh, well, I understood this. Thank you.